right, so the last set of filtered samples that we're going to do are for DOC, dissolved organic carbon, and those are in amber bottles like this. And we don't use the disposable filters with those. We use ashed and weighed GFF filters, and those we can also get total suspended solids off of. So the filters are already in these tiny Petri dishes and have been weighed, so they have a code on them, as well as the information around the weight, as well as the sample. So we need to load this filter into a filter cartridge. The way I like to do that is to unscrew this and flip it upside down, taking care not to touch anything on the bottom of the filter cartridge with your hands if possible. You need to take the filter out of its little Petri dish case. And the way I like to load them is into the top of the filter cartridge, and that's because we get wind a lot in the Great Plains, and the wind can kind of sweep your filter away if you're not careful with it, or if you leave it up on this top piece. So I'm going to take, with these forceps, this filter and load it into the top portion of, and hopefully it doesn't blow away there, of the, there we go, of the filter cartridge. And then screw these two pieces together. And then preserve your little Petri dish case. Then this is ready to have water push through it, just like our disposable filter. We need to rinse the filter. Whenever you're doing TSS, you need to know the entire volume that goes through that filter, including the rinse water. So this one's just sitting at about 55 mils, so I'm going to push 5 mils through. You'll see that starting to go through. And then we can go ahead and proceed with the rinse procedure for our bottles. So this is the same as what we were doing with the cations and anions. We're pushing about 5 mils in to rinse. 5 more mils in to rinse. Another 5 mils to rinse. And then this sample is ready to collect. And so we have about 35 mils that we can load into this bottle. This is a 60 mil bottle, so I'm just going to fill it up with the remainder in the syringe. Anytime you're using a cartridge filter like this, you want to watch the seal area and make sure you don't see any water leaking out the side. If you start seeing that happen, that means that your filter is compromised and your sample needs to be restarted. It's not intact sample, a filtered sample, a reliably filtered sample. I'm going to see if I can get this whole sample through this GFF filter. It's very murky. All right, that's as much as I'm going to get through that one. What I would do now for this TSS filter is note that I was at 55. I got down to, what is that, 16 mils left. So you would take 55, subtract 16, and write that volume on your filter as the total volume that went through the filter. And then we're going to take a little bit of air and push that through. You can see at the very top of that, there's a little bubble there. There's still water captured in the top of that filter cartridge. And if we were to unscrew that, stuff would just kind of slide out. That's not ideal. So I'm going to try to push that water through with just some air. You can kind of see it dripping, and that bubble starts to get a little bit smaller. And that dries out the filter a little bit too. Makes it easier to remove. So that is going to go then into this Petri dish again. And you pull it off very gently so that we don't disrupt the filter. You should see a nice, clean white line around the filter. If you don't see that nice, clean white line, that likely indicates that you didn't have a good seal with this O-ring, and that sample needs to be retaken. That was a compromised sample. So then we would cap this, write the volume on the Petri dish, and then send it back to the lab to be dried, and send this sample off to be analyzed for DOC.